So now we're going to talk about that whole restricted domain type thing here. But let's go back to just kind of some things that we know, a little review. It says find the inverse of, and it gives us this function. Well, here's the restriction right here. We'll talk about that in a minute. But if I just had f of x equals x squared minus 1, we know what that looks like because we've done transformations. We know it's your common function, the parabola. So, the parabola normally looks something like that, but it's shifted down 1 unit. So it's going to be, all those points are going to move down. And it's going to look something like that. I didn't draw a very good graph, but that's what it's looking like, okay? Well, there's a problem with this because if we're in the world of inverses, it's not 1-to-1. Okay, so it is a function, but it's not a 1-to-1 function. So this is where the restriction comes in. And the restriction says, oh, we're only going to let x be greater than or equal to 0. So we're only talking about x values from 0 to the right. So basically, we're just going to ignore this half of the graph, okay? And that's what we mean by the restricted domain. Now it's 1-to-1. I can graph this. Okay, so I think I'll graph it in orange. And you could do a table of values here. Or you can use the transformations. Let's see. I hope I counted that right. It should be 1, 0, and then 1, up 1, 2, 1, 2, 3, 4. Okay. And then we would have 3, 9, 1, 2, 3, 4, 6, 7, 8, 9. Something like that. Okay. And so it's looking like that. Now, you could just graph it based on what we did in the last example. Okay. But you can see that this is 1-to-1, and it's a function, and so it's going to have an inverse. Now, one question you might have at this point is, well, why did you take off, this part? Why didn't you take off the other part? You could have had this part, and that would have been 1-to-1 function as well. Yeah, you could have. They just chose to make it x is greater than or equal to 0. They could have gone the other way and said x is less than or equal to 0. That would be different. The graph would look different, and the inverse would look different, and the inverse function would be different too. But they just restricted it this way, so we'll go with what they said. Okay, so there's the function. That's all we've done so far is we graphed the function. This is f of x. Now we have to find the inverse. Okay, so take the function and put in the y equals x squared minus 1, and the restriction is that x is greater than or equal to 0. Now we're going to switch x and y. And notice that I also do it for the restriction. Okay, so we switched x and y. Now we got to solve for y. And now we've got to take the square root of both sides. Okay, I am not putting in the plus or minus. I guess I could temporarily put it in, and then I'll change that. But right now I have plus or minus the square root of x plus 1 equals y. However, the restriction says that y has to be greater than or equal to 0. So I can't have the negative case. I can only have the positive case. And I have to do that anyway because it wouldn't be a function, right? So I have to restrict this. So I'm going to say y is equal to just the square root of x plus 1. Okay? And you can include the restriction y is greater than or equal to 0. But watch what's going to happen here on the next part. So I put in the inverse notation. But what's really going to be the restriction here? Like, look at just your inverse function. Doesn't x have to be greater than or equal to -1? It does, okay? So here's the function. It does have a restriction on x. It doesn't do me any good to have y restriction because I don't have a y anymore in my equation. So I've got the inverse notation in terms of x. I've restricted x based on what we know about a square root function. That it has to have a positive argument in there that you're taking the square root of. So x has to be greater than or equal to -1. We know it's going to be the positive case based on our restriction right here. When we did that, we said, oh, it's got to be the positive case and not the negative x plus 1. Okay, can I graph this? Well, yeah, this is going to be, it's going to have a horizontal shift. It's the square root curve, right? So it's looking like that, kind of. And it's going to shift horizontally 1, so to the left 1. Yeah, it's a horizontal shift, but it's going to the left 1. Okay, so I can think about the normal square root curve. You know, the normal square root curve would have been like that. Anyway, I don't have it drawn very good. Here's the normal one. 0, 0, 1, 1. Trying to use my transformations here. There it is. But now we have to shift it all to the left 1. So it's going to be, that's really going to be in my way. So let me see if I can get that out. All right. Shouldn't have tried to draw it. Okay, and that's going to be 1, 2, 3, 4, 2, and then 9 from that point. Okay, there's the F inverse function. And does it, you know, reflect about the diagonal line? It does. Okay. If I draw it right, it does. Okay. So that's how you do it. That's how you take care of the restriction. It's really kind of two things you're looking at. When you took the square root of both sides, you had to decide, okay, is it going to be the plus case or the minus case? Because I can't have both. And it's that part's based on this restriction. But then I have another restriction when I get, whoops, on x, when I look down here at the actual inverse equation, I realize, oh, I can't have x be just anything. I've got to restrict it, right? So that's where this restriction comes from what we know about square root functions. Okay? All right, but it graphs nicely, and that's the function and its inverse, and it's a little bit tricky.